Welcome student into my second video about the series of the RabbitMiner, and in this session I'm going to continue to use for our previous example of the house price prediction, right? You already had download for the data sets and save it and load it into your RabbitMiner, and that will be a great thing. So today we're going to talk some other topic, like we're going to see about some chart of RabbitMiner. Another part could be like data partitioning. That will be one of very important part for machine learning. And also we try to do the modeling on the regression model with the machine learning methods that different to the regular and traditional or conventional linear regression model. We learn also how to validate the model performance, and finally learn how we can save the process into your computer. So in that case you can just repeat and reopen for all the progress again. Okay, one more time we're going to just use with the data set house price. Okay, and I already opened for the RabbitMiner over here, and now let's one more time read the data into our computer. So I use CSV, right? Because this is a CSV file. This is not a regular Excel file, but like comma separated. So that's why I use the CSV and I drop it here. Okay. So if you feel it's okay, so over here I will just load the data and I will set it into the result. So here now I'm going to import for the configuration results and allocate my data into the right repositories. So the directories of my data will be where I save it over here in the module number 5. Okay, you would just use it like the same way you're doing, and I will go and click and next. And with here I have no problem, so I'm going to say next, right? And I also don't have other kinds of problem about the data type. So this one will be integer, this one will be integer, this will be real data, integer data, real data, integer data. If some of you guys ever have C, right, we can change the row of that one into the last so bright, good like the touches, or you can say the level. But here I will just like give an example when I forget about that, and I just put all the thing and save everything very quick. And I finish about that one. Okay, so in this case, if I just run the data, so all the data will be look like this, and there is no kind like the real result. That's which one will be like the target data or something. Okay, so we are doing some missing, but don't worry, we can fix the problem anytime you want. So if you want it just from this data set, right, from the result of all the variable we are having 1, 2, 3, 4, 5, 6, 6 different variable, and I want to set like last so price like the target variable, or we say the dependent variable. We can do it by setting the row of the data. So I've used the function set row. Okay, that will be from the blending attribute and the name rows folder, and I drop it here right on the connection between the CSV and the result. Okay, so that's way they understand that I have to interfere all the thing by the set row process function. Okay, so this one I can use the attribute name like with me here, right? I want to just set it into the last so price into the label. Okay, and that should be the only thing. You can also set for the additional row, but with here everything will be good with me. I just want to set for the last so price into the label, and now I run it one more time, and you see, voila, right? You see that's one, the last so price has become the charges variable, and it has been highlighted with the green color. Okay, and you can also see the same thing was as we already done before, and I talked with you about the numerical descriptive statistic. Now let's go and see with the some of the other things, like I say some of the other charts in RabbitMiner, right? So we have discovered about statistic tab, but we didn't see about the visualization tab. And yeah, let's see about some of the thing here. So maybe I would just over here about the chart. I already do this one, but maybe I will not do that. Okay, And for example, now my question could be like I want to seek about the result, like the relationship between the last sale price and also for example about the house square feet. Okay, house square feet mean the area. So we may think like the larger the house is, the higher the price of the house could be nominated, and we can think and see about that one based on the scatter plot, right? So I want to see about the scatter plot. So in one side we have the x-axis, and in the other side for the y-axis, that basically will be the touches variable. So the last surprise had been set over here. But of course I don't want to see about the year views, but like I want to see about the like house square feet. Okay, and this will be the thing. So in the kind of like the horizontal axis, we have the house square, and from like 1,770 into like 3,800, and the last surprise that's ran from 175 to like 475, and you can see over here, right? It look like the higher square feet, right? The higher square feet, the higher sale price could be. So it looks like there's like positive relationship between the area of the house and also for the last price sold. However, that's not everything I want to say about, right? I want to talk about the other type of stuff. For example, I want to see about the relationship between, for example, the years of build, the build years, right? So I want to see like what could be the relationship between years build and the last sold price. So people may think like, okay, with the very old, okay, if I ran all the thing by the year, okay, you can see like with the very old building, with maybe back to the 1990 compared to the 2016, it looked like the building with very old house, right, been made by 1990, they normally get the lower price for nominated. Okay, but we're not sure about that, so we're going to use this for the data visualization to going to see it. And I'm going to choose for the bar. So of course over here we have a lot of other kinds of stuff, but I'm going to just use for the bar column chart. All right, so yeah, we will see like, yeah, there are too many of them like in the bar column chart, and I change for the x value will be into the year view, right? And the value column will be the last sale price, and you can see that this will be all the things that be separated. But however, I use aggregate data, and instead of the like using cow or something, I will use the average. So I can see like in 1990, right, the average of the price of all the house in 1990, built in 1990 will be $200,000. Why in the 2016 all the house that sold were built in the 2016, they normally make it like $440,000. So yeah, hold on, we can say like with the newly built house or property, normally the people will make the higher pricing for the house. Okay, and you can also try with the other kind of stuff, like for example, I just not want to see about year build, I want to see about the bedroom, okay, number of the bedroom. And yeah, it look like the in average the house with 3 bedroom is cheaper than the house with 4 bedroom compared to the 5 bedroom. So of course, the larger the house, right, the more bedroom that they have, the higher the price will be. So it very makes sense about this data. Okay, I think that should be quite enough with the first part about the visualization. So let's come and see about the other kind of stuff like data partitioning. So data partitioning will be like, in here I want to separate my data into the training data, okay, and the testing data. Okay, testing data with the proportion like training data 70%, while the testing data will be just 30%. Okay, so that should be the data partitioning. So in machine learning model, even like just regular linear regression, we need to use the training data from the 100% of all the data set, They separate them into the training data, like 70% of all the data sets, to use and create for the model, to train for the model, to just make it learn about the model. That's why the people call machine learning. And then after, when you already create for the model, you test for the performance of the model based on the testing data set. Okay, you compare between the result generated by the model compared to the actual data that we already collected. So that's what people call the data partitioning. And to do that, very easy. Okay, you use the split data. Okay, and this will be in here, the blending and one more time sampling, about splitting the data, and we will do it like this way. Okay, so with the splitting the data, they will have some methods like linear sampling, shuffle sampling, stratified sampling, and automatic. I will just do it automatically. Why we have to do for the splitting the data? Let's take a look into the original data first. If you normally do for the sampling, right, you will have to just separate the data by yourself. And is there any kind of way to just do it? Let's see. If we have up to 120 observation over here, right? So you can see, like, you can create for the first part of the data into, for example, like the first 100 observation to be their training data set, and then for the rest, right, this will be the testing data set. But however, there is no thing that can guarantee that all the data you select for the testing data sets and the training data sets is a randomly selected sample. Okay, you just do it by yourself and you select it by the order. Actually, you can do it like you select for the first one, the second one, the third one, all the thing go into some into one sampling. But that's not a good way, right? That's not a good way, because nothing can guarantee that your data is randomly selected. Okay, so that's the reason why when you choose for this one and use it with Excel, it's not so easy to just do that for data splitting. But however, in RabbitMiner, it's very easy to do that one. Okay, and you can just do it with the ratio, so they understand that the first part I say here, right, I want to have 70% to be the training data set and the 30% for the testing data set. So I just put in like 0.7, and another one, right, of course 0.3. So 70% will be for testing data, 30% will be for the 70% will be for training data, and 30% for testing data. And I say okay. Alright, so this will be the data separated. Okay, this will be the data separated. So if you want to see about that one, and if you run for this one, okay, so you can see the split data. So this will be the testing data of the, this will be the test data with the 36 observation. This will be the first part. 36 of 100%, 120 observation from the original data, right? You can remember. So that will be 30% of the 120 observation. While the other 84 example of 84 observation here, this will be for the testing data set. Okay, and of course you can also see it in the different testing or the other kind of stuff. Okay, so maybe we can change the name of this one if you want, to just say about that one, like which one will be the testing data, which one will be the single data. That will be totally fine. Okay, now after when you already create for the data partitioning, right, with the 70% of the training data and the 30% for testing data, let's create for the linear regression machine learning model. Okay, so to do that is quite a simple. Okay, so let's stop saving about that one first, and then here I will try to find for my function linear regression. Okay, and they will go into modeling prediction function, and we have the linear regression over here. It's quite a straightforward to see about that one. So of course with the splitting data, you can get like two different data. Okay, so first part, like you can link the testing data, right, the training data. So you can see over here, okay, you can see over here that will be you have the 80, you have the 80 for example or 80 for observation. That's you for the testing, sorry, for the training model. While the other right here will be like the rest of the data will be you for the kind of like testing example. Okay, so when you create for the linear regression, you can choose about all the kinds of information like M5 prime and the tolerance, like the significant level will be like 0.05. That should be very normally very kind of like advantage. Okay, and finally, when you already got for the linear regression, you also have to test the model. So you use the function apply model, okay, scoring apply model, and you drop it here. So to do that, first of all, you have to link between the model created by the linear regression model into the apply model input, so they understand that this will apply the model created by the linear regression. Okay, so by create linear regression. And second of all, you also have to compare, right? You also have to compare between the result created by the linear regression and also compared to the testing data set, right? With this one, okay, so with this one you will just apply for the apply model. Okay, so in this case, if I just stop it here, I want to see about the result. Okay, if I just want to see about the result of the model, so I'm going to you and run it for the model, and you can see this will be the result, right, when you already run for the model. First of all, for example, this will be the model itself, right? You run it with the charges of the price. So now you have a four different other kind of like independent variable. So including like houseware, number of bedroom, number of the year bill, and the total assets. Okay, so they will just remove for the number of the bedroom or something, right? Because they may be not significant or something. Let's go and check it. This one, why it's just like have a few of the other. Okay, and this will be the result, and this will be the result. Let's go and come back and run for the model one more time. Okay, so yeah, we still have the number of the bedroom, but it look like when you run for the regression model, this will be just described it over here. So yeah, true, number of the bedroom has already been removed, but you will feel like it's very the same with what you are doing with the normal regression model, right? With the normal regression model, so you can see like this will be the coefficient of the variable houseware fit. So now they have a positive effect into the price. Number of bedroom, actually they have negative effect. The year bill, they have the kind of like positive effect, and also like the tax of the assessment year. That means the tax is higher, the higher the price could be. Yeah, so this one, and this one, they have the kind of like the significant level. So for the number of the bedroom, they have significant level like 0.1. Number of the house square feet, they have the significant level as 0.05. And finally, with the tax of the assessed value, they have the kind of significant level. It's very low, 0.01. And that's the reason why we have to like 4-star over here for the symbol. And also, we can see the estimation about the prediction, right? Based on all this data, they can create for the prediction about the last price. That's quite close to the original data, like close to the testing of the data itself. Okay, so it's very close to the real data, the actual data. Alright, so this will be how we can create for the model, and if you go and see about the result, you can just create for, okay, if you go and see about the result of the model, right, you can see it's quite the same with what we are doing in this one. Okay, so this will be how we can just demonstrate about the model, and I just make it easier for you to understand. When you put all the coefficient into one of the regression function, and all the thing can be written out like this way, written out like this way. Okay, you can read it further. Okay, and you can also create for the linear regression model like this way, the same with what I'm doing on this one. Okay, on the PowerPoint slide, and that's the basic thing. Last one. Okay, so the last thing that I'm going to talk about will be like the validating of the model performance. So when you already run for the model already, right, you will have to know that your model is doing well or not doing well. Okay, so that will be the point here, and this will be the time for us to just demonstrate that one based on one of the things what people will normally say. Yeah, let me just change this one a little bit. Okay, so this will be the time for us to just talk about this case when you want to just run it like in the performance function. Okay, so if you go and see about the performance, so you can see like about performance of the regression, and I will drop it here. Okay, so with the performance, like one more time, I just remove for the relationship. So I will put them in the middle between the apply model, because I have already get the model, right, and I can also see about the result. So I put them into the performance, and I link like this one also for the model, and I link for this one. Okay, so I just want to have this one, and I want to seek about the other requirement, like for example the root square of the average. The first main criteria, we can do it like the other type stuff, but I will just use this one, like root means square root, and also for the other kind like correlation, the square correlation, whatever you want to just go for this one. Okay, and potential problem detected, I don't know why. Okay, I will just remove for the second relationship, check it. Okay, and if you want to just go for this one. Okay, so I'm going to just run for the model to see for the result, and they tell me about the result of the performance. Okay, including for the root mean square error, like the correlation or the square correlation. So this will be the performance of the result. Okay, and you can see this one. Okay, so this will be the result for all the thing. The other cap start. Let's go and run starting point. Okay, got it. Oh no, one more time. Yeah, result, and also here I have the other cap result, including like the performance, and also for the result of the model. Okay, so that will be the point. So in case like over here, you already learned how to just import the data, set it, split it into the partitioning, run for linear regression, and just do for the performance assessment. So in case like you want to save all the result, you can go and click here and say like save the process or save process at, and you can link and save them into your computer, whatever you want to just say, and the name it would be like, I would say, let's give it the demo of the model file 1. Okay, number 1, and I say okay, and this will be had been saved already. So next time when I just want to just run for the model, we can see about the result. And thank you so much. So this will be my second video about how you can run for the machine learning model on RabbitMiner. Hope that to see you in the next video, and we're going to just create for some clustering analysis on RabbitMiner too. See you soon.